Alright, Chapter 2, Tamping Machine and Dynamic Track Stabilizer, our DTS, TM, and DTS. Government Indian Ministry of Railways, Railway Board, Indian Railway Track Machine Manual, 2nd edition, September 2019. Alright, Chapter 2, Tamping Machine Dynamic Track Stabilizers. General purpose of the tamping stabilization of the track of the ballast bed is to produce the compact sleeper support in order to improve the local distribution of the sleeper to restore the track the current geometry, have long-lasting relative of the packing. Tamping machines are used for the correcting track geometry, tamping the ballast with the dynamic track stabilizers, used for the better anchoring of the track skeleton in the ballast bed to improve the durability of the track geometry under running traffic. 202, Tamping Machine. Tamping machine measure the existing track parameters, lift and enable the correction of the cross level of alignment to achieve the target of predetermined parameter values, which aim to improve the track geometry. Simultaneously pack with the ballast and the sleeper to use the tamping tools fitted down with the tamping unit to provide well-compacted ballast bed. 1. Functions. The main function of the tamping machine are to correct alignment, the correct longitudinal cross level, the tamping, the ballast, and the sleepers. Some of the tamping machines have additional fitments of the track ballast stabilization also. 2. General layout. General layout. Important units of the tamp machine 0932 CSM are shown below. Shows a Figure 2-1 from the top. Rear working cabin, level cord satellite frame, lifting lining unit. Front cabin, front for trolley, front bogie, lining trolley, tamping unit, satellite wheel, measuring trolley, rear bogie, wheel, rear trolley. 203, important assemblage for the tamping machine. Engine. The diesel engine, main swivel, the power of the engine converts the chemical energy fuel into the mechanical energy as part, usually directly into remaining further converted with the different forms of power for a working machine. A. Mechanical powers of the gearbox appear and power over the mechanical power generated with the means of the hydrodynamic gearbox. Most of the machine's movement of the tamping machine remaining in mechanical power is converted to the other forms mentioned below. Hydraulic power through the hydraulic pump. Hydraulic power is generated with the means of the hydraulic pump driven by the mechanical powers provided with the power operation during the working through the various hydraulic motors. And cylinders. Pneumatic power through the compressor. Pneumatic power is generated by the means of the compressor driven by mechanical powers to achieve with the brakes and unlocking systems with the assembly up to the down movements of the feelers, operating bogies for datum selection, horn operation, and cord attention, etc. D. Electrical power through alternating batteries. Electrical power is generated through the alternator source from the batteries. Used to provide electrical power sensitive device feedback of the corrected parameters, signals of the hydraulic units of leg. Differential valve, proportional valve, the servo valve, the operation. Tamping units. 2 or more independent tamping units provided with the tamping machine, one or more of which each of the rails, depending on the make of the model of the tamp of the model of the machine frame, with the means of vertical guide columns. In some of the machines, tamping units are fitted into the satellite frame. The tamping unit of the independent railway is capable of tamping 1 to 2 or 3 sleepers at a time, depending on the type of the model of the tamping machine. With the tools arranged for the pairs of each of the 2 sides for the sleeper of the tamper with 4 such pairs, 4 numbers for each side of the rail. Units held on the horizontal guidelines column in order to slide with the sideways, which will allow for the manual automatic centering over the rails and curve. The tools are vibrated by piston rods pivoted with the eccentric shaft, driven by hydraulic motors. Typical layout of the tamping of the different components are shown in Figure 2 with the lifting, lowering, tampering units achieved with the means of the hydraulic tamping unit lifts of the lowering cylinder, inserting the depth of the tamping tool, squeezing the pressure of the can be varied through the different types of sleepers. Case simultaneously tamping the double or triple sleepers with the only opening with width of the tamping tool change with the pneumatically changing the clapper pieces to suit the sleeper opening a pneumatic and by opening a pneumatic operation on the clapper similar to the joint sleepers. Alright, it shows the 1 tamper 1 on the 1 tampering bank, 2 center pin, 3 big tampering arm, 4 big squeezing cylinder, 5 guide rod, 6 oil bath, 7 plate guard, 8 clapper cylinder, 9 squeeze plate, 10 small squeeze cylinder, 11 small tampering arm, tampering tool. Alright, the tampering tool, size and shape of the blade with the tampering tool have the bearing over the quality of the compaction of the tamping of the ballast side with the tamping tool with the difference depending on the model make of the tamping machine with the tamper tool with the carbide shield to call the tungsten carbide tamping tool are known not to be are known by being used to improve the performance half of the position of the tampering tool with the various machines. The important decision depicted the annex of the figure 2-1. Lifting and lining unit. Lifting and lining unit position in front of the tamping unit. Lifting is carried out with one using lifting string with a help with the roller clamps with a hook on each side. Lining operation starts simultaneously. Lifting operation assumed with the target value with the reach with lining and lifting with the operation are automatically stopped. Satellite unit. Continuous sleeper tamper machines have the tampering lifting cum line unit provided with a separate unit called the satellite unit. Satellite unit is placed with the independent unit frame, which is mounted on the wheels. It can move independently with the main frame, capable of the cyclic movement of them to the sleeper, the trolleys. There are wheels mounted on units provided with the sensing in the field with the measurement correction of the track parameters. 4 trolleys with the tamping machine, which are front trolley, for lining trolley, height of the transducer trolley, and then measuring trolley, rear trolley. 7. The brake system. Found when the type of the brake system provided with the tamping of the machine. Direct brake is applied only when the machine during transit. Indirect brake is the application of the machine coupled to camping coach wagon while running. Brake system is provided. The machines with the KE valve is available in all new tamping machines. It works like single piping system. Emergency brake. The brake is applied with the machine during the transit alone, coupled with the camping coaching wagon only with the CE valve that is on the open on position is allowed through the indirect braking system. Safety brake. The brake is applied with the automatically switching off of the hydropneumatic transmission gear with the ZF gear with the Placer machines. Normally, they should not be used for the surface brake application. Parking brake. Hand-operated mechanical brake applied when machine is stabilized. 204 types of tampering machines. Tampers without satellite. Tampering unit lifting come line with the mounted with the mainframe of the machine itself. The machine move the tops of every sleeper for aligning and leveling, tamping one of the 2 sleepers that can be the tamp for the simultaneously one operation found with the machine falls into the category. A pneumatic plane track tamper. A plane track tamper is a 32 tamping tool to unpack 2 sleepers at a time. The machine also referred to with the worksite tampers for purposes of the nomenclature of the names of the model of the pneumatic tamping machines presently in use of the on Indian Railways name of the manufacturer given below. The 0832 Domatic Placer India, 0832C Domatic Placer India, 0832 WST, and Flat Car Mettex JSC Moscow Russia, VPR 02M without flat car column push out Russia. The important feature dimension of these machines are given in the annexure to Alright, you have your Unimat post, points, and cross tampering, primarily with the points cross the tamping machine. The tamping unit is designed with a manner involved with an independent operation with an individual tamping tool. With the help of the tamping almost all of the sleepers from the point of the crossing tamping tool with the infringe with any of the track component can be tilted with an individual arm and the pairs rest with the tool with the tamp. The sleeper the tamping with the units must be with the machine that can be rotated with the line with the sleepers which are laid in an angle, fan shaped layout, design, advance of the unit, map with arrangement, third and lifting the third rail and move with more advantage for the provision. For both lifting as well with the packing on the third roll, various models of the U and E map machines presently in use for the Indian Railways where the name of the manufacturers are under 08275 Unimat, 0827530S Unimat, which arrangement only for the lifting of the third rail. U8084754S Unimat Placer India with arrangement lifting packing under third rail. Important features to mention: these machines are given in the annexure U3. Multi-purpose tamper with a plane and plane points with a crossing tamper. This machine that is designed to spot and tension with a plane track as well with the cross, well as point and crossing. May have a flat platform rear end of the crane for facility loaded, unloaded transportation, and permanent way material. Various models with the multi-purpose tampers presently used in Indian Railways are given. Unimat Compact PMMT, Unimat Compact Split Head MFI. The important feature dimension for these machines are given in the annexure 2-4. Alright, 2. Tampers with the satellite unit. These machines provide with the satellite unit which move independent with the main machine working mode. Components required with the tamping line, leveling with the tracker provide with the satellite unit with the main machine that moves at a uniform sleep speed continuously. The satellite unit moves, stops every sleeper set with a living, lining, and leveling tamping with these machines due twist and correction. The different modes of these types of the machines can be the tamper. 2 to 3 sleepers in one direction, the machine falling in the category R, the 0932 CSM, plain track tampers. Plain track tamper is designed to line level, twist correction tamping over the sleepers. It also tamping unit with a 32 tamping tool will tap the 2 sleepers at a time. Single cord lining, double cord, parallel leveling system. With an important feature to mention for the mag given in the Annex 2.5. Temperature expressed in 0930X plain track tampers. This plain track tamper define the lining levelly with a twist and correction tamping of the sleeper that has 48 tamping tool with the 2 tamp 3 sleepers at a time. Single cord lining, double cord with the parallel leveling systems are with the important features to mention for these machines are given in the Annex 026. 2.5. The tampering mechanism. Tamping units work in accordance with the asynchronizing constant pressure. The tamping principle with the tamping tool penetrate the ballast and perform a closing movement. This incidental vibration shown in Figure 2.3.
There for a minute, now it's gone.
Maybe it's something on. Alright, 205, tamping mechanism. Tamping units work according to the synchronized constant pressure tamping principle. The tamping tools penetrate the ballast, performing the closed movement of incidental vibration shown in Figure 2.3. Alright, shows the squeezing forces to the left and right in centric vibration shaft, fixed pivoted to pick up the tamping reaction forces. You have 15 to 20 millimeters, a synchronizing action and a squeeze. Tamping tool continues to move with the pressing of the ballast till the desired force of the breach of the rest. Each of the tools apply with some force of the ballast, and each of the tools continue to move with a different duration pressure of the ballast till the desired pressure of this reach of the process is unknown. With the synchronizing constant pressure tamping operation components of the tamping are shown in Figure 2.3. All tamping tools there all apply with the same amount of the pressure of the ballast being tamped. Thus, their equilibrium forces between the individual tool pairs. And specifically serve the pressure of all tools so that during the tamping of the valve, the resistance gets built up in front of each of the pair of the tools. Movement of the tools is completely independent according to the resistance encountered with the ballast. Once over the resistant reach of the pre-selected value, hydraulic pressure in the squeezing of the cylinder of the corresponding tool of the pairs stop automatically. However, the other tool pair continues to squeeze until the resistance of those that becomes equal to the pre-selected pressure. The individual tools have the different closing movements as shown in Figure 2.4. So it shows W1, W2, W3, W4, tamping parameters, squeezing pressure, squeezing with the force of the per unit is effective the area squeezing is called squeezing pressure. The force phase for the tamping tool with the consolidation over the ballast will correspond with the squeezing force of the tamping unit presently available to Indian Railways. Scoop the pressure for the different track pressures below. Plain track 90 to 110 kilograms squared. Centimeter squared. Plain track 100 to 110 kilograms centimeter squared. Plain track 110 to 120 kilograms centimeter squared. PNC and ST and wooden 110 to 115 kilograms centimeter squared. PNC and PSC 125 to 135 kilograms centimeter square. Squeezing pressure should be kept on the higher side of the stipulated rim with the CAG ballast side with the deep screening side with the newly laid tracks with the unconsolidated ballast bed could be on the lower end of the range. Tampering depth for effect with the tamping of the ballast below with the sleep of the under of the rail seat with the gap between the top of the edge of the tamping tool blade. Bottom edge of the sleep of the closed position of the tamping tool should be adjusted depending on the type of the rail and sleeper for the desirable gap between the top edge of the tamping tool blade and bottom edge of the sleeper. The different type of the sleepers will be understand to do obtain with the table 2 show the type of the sleepers. You have the flat bottom sleeper with the desired gap at the top edge of the top 2 of the blade with the bottom edge. The sleeper is 15 to 20 millimeters and metal sleepers are 20 to 25. To aim correct depth of the tamping tool during the package for the sleeper, the initial zero position of the table tool is shown in Figure 2.5. Shows 15 to 20 millimeters. The tamping tool depth is calculated with the tamping tool depth equals the sleeper depth at the real seat location. You plug for the rail height, rubber pad thickness, and it shows an equation. Tamping tool vibration amplitude frequency for the tamping tools are vibrated piston riveted with the eccentric shaft driven with the hydraulic motors following with the parameters. Parameters: rate of revolution, vibration, shaft 2,100 RPMs, vibration frequency, tamping tool 33 to 35 hertz approximately, amplitude of oscillation 3 to 5 millimeters, the value of the variable may be dependent on the design, model, makeup of the tamping machine, with the technical manual of the machine may be referred for details of all such parameters. 4. Vibration pressure. The vibration pressure for the tamping tool. If the vibration does not slow down with the top, even with the penetrating with the valves, the vibration pressure vary with the machine to machine goes from 150 to 210 kilograms centimeters squared. Tamping cycle with the squeezing time of the complete tamping cycle involve the loading with the tamping unit if the desired depth of the squeezing of the valves till all of the tool's parts of the predefined squeezing pressure. Holding the tamping tools into the position, releasing, lifting with the tamping unit into the driving, traveling tamping until the next sleeper location of the taken and screw with the valves for the pre-select. Pressure is called with the squeezing time. The normal step of the machine, such as lifting and lining of the track structure for the start of the tamping unit lowered about 100 millimeters from the zero position. Squeezing action commences about 30 millimeters before the tool reaches the target depth. Squeezing. Shove the tamping depth 30 millimeters, 100 lifting, lining, squeezing, holding, squeezing, lower out TF unit, lifting TL unit, traveling ahead in time and tamping cycle. Circuit is cut off with the present squeezing time of the complete with the tamping unit lifted in succession. Lifting line circuit is cut off with the tamping unit with lifting operation 100 millimeters before the zero position for the maintenance backing. Squeezing time of the 0.8 seconds to 1.2 seconds and should normally be adequate. Higher value above the range squeezing time is required for the track called the cake ballast. 6. Tamping tool. Surface area with the tamping tool blade. The different machines is given in the annexure 2.1. Tool more than 20% of the wear of the original surface should not be used with worn or if the tools are to be reconditioned or replaced. 207. Optional equipment. The use of the optional equipment, the laser beam system, the geometry value assessment, and the ALC system, etc. Simply working with reduce the arrow proneness associated with the manual system and with the data collection feeding of the system as briefly described below. 1. Laser beam system, a fair photo cell with the mount with the tamping machine. Receive the fan out laser beam with the laser emitted with the case of the unbalanced laser input. Receive the photo cell with the corresponding with a different signal that activates the electrical motor to move the whole. Receive the assembly along with the front end of the cord with the center of the laser beam, front of the door with the end of the cord, and shifted laterally with the mount with the air to enable the design, lining, and leveling working on a laser beam system is explained in Annex 2 through 7. Geometric value assessment. As a small computer would eliminate the feeding adjustment value with the table, the making of the marking of the sleeper, the location of the main point with the curve of the tongue, with the transition length, and radius, super elevation data, etc. are fed into the computer using the geometrical value assessment. Eliminated the necessity of attention from the operator feeding of the values. Thus avoid possibility of mistake with the calculations or feeding of which result with a better progress with improved quantity. The automatic guiding computer, or ALC, an advanced system which automatically calculates the value of the various track parameters feed into the machine basic target track geometry, has the capability of measuring and recording existing track parameters during the measuring run in advance working, and also allow flexibility to achieve the desired track geometry. Also save the operator from entering various parameters into the feed, but it does automatic feeding or parameters of the detail working with the system design in Annex 2A. The automatic guiding computer system are being provided with the fault finding diagnostic software also. 4. Your data record processor system is a system with the record tracking of the parameter during the working operation, working speed with the machine with the records with the parameter with the tam track with the uneven alignment with the cross level with the twist with the measuring sensor with the sum of the mount with the tamping with the track with the parameters record with the working direction with the machine. It also has system predefined limits of the individual parameters possible. The value of the classified with the measurement of the result of the parameter can also be displayed with the graphically along with the calculated same of the deviation of the different parameters. Small lengths say with the 200 meter section. A part of the track parameters that can also be designed to report with the machining working parameters like squeezing pressure with the squeezing depth. 5. Computerized measuring system, the CMS. Onboard computers will display with the track parameters measured with the super elevation versus sign with the longitudinal level that also display with the nominal value with the feed with the operator also display lifting and lining values manually through laser system, although with the automatic gain, automatic guided computer system. Separately, you with the digital calibration, lining, and leveling the calibration system controlled by the using turbo value of the diagnostics enabled from proper working of these units. And Alright, your computerized working shift the computer receive the various machine working parameters controlled with a proportional value from the circuit, the sum of the which are listed below the display of the monitor, driving the RPM engine of the work of the driving speed of the run drive speed, etc. for the tamping, depth of the tamping position, speed up and down, tamping unit, squeezing pressure, squeezing time, satellite drive, with the provide the satellite speed with etc. for the automatic position, sleeper distance, setting of the during with the automatic working. Also, you the setting of the above of the parameters, tamping of the parameter like tamping the depth of the squeezing, the time of the squeezing pressure, satellite forward with the reverse speed, etc. Lining system. Lining system is measured for the correction with the track alignment, single with the cord alignment is off with the tamp of the working with the engine rail with the cord strap with the front with the rear of the trolley, with the measuring alignment over the track with the measure of the transducer for the track is salute, but lifting come line unit over the targeting and alignment for those purposes aligned with the machine measure for the alignment with only one pre-selected reference rail with the rectify of the rail with the reference rail. The alignment of the other rail begins fixed with the sleeper that automatically gets rectified with accepted for the corrective of the cage current defect. Verse line curve of track depends on the radius for the curve of the cord length with the measurement location of the measurement. Reference rail with the reference rail carry out with the tension of the alignment should be selected as given below. On curve track with the outer rail with the outer rail with the highly worn out with the inner rail should be taken as reference rail. And on the straight track, the single, the double, the middle lining, multiple line sections, and two rail with the track may be tamped, which is left with disturbed. The lining method. Tamping machines follow with two methods of alignment. The correction of 3 and 4 points. Some of the latest machines have the provision only 3-point lining method. 4-point lining method selected reference measure with the 4 points for the curve taken with the two measurement the verse line with the value for the compared with the correct geometry for the method reduces existing error significantly to improve the track alignment. 3-point lining method. Selected reference rail with a measure for the 3 points for the and lifting and the lining is performed with the measurement of the middle measurement reach for the target of verse line value with the method restore the geometry to almost perfect provided go the correct measurement as a feed. 4-point lining method. 209 4-point lining method. Lining principle. The method can be used with the correct alignment only when the curve track of the method is measured for the 4 reference points and when the verse line measurement of the 2 intermediate points will compare with the geometrical verse line ratio relation. The control lining of the principle will follow within the circular curve of the verse line with the measure for the pre-decided with the location cord given the length that will have the fixed ratio that's depending on position and measuring point of the verse line ratio of the constant is independent with the radius for the circular curve of the 4 points of the machines are below. Shows rear of the trolley, the measuring point of the cord, the tampering unit, lifting lining unit, lifting alignment, targeted curve of the existing curve in front of the trolley, direction and work. Here A is the rear of the trolley, location B is the location measuring trolley, and then C is the lining of the trolley where also first line of the measure correction done. D is the front of the trolley location. Trolleys at A, B, C, and D are pneumatically pressed against the outer rail with the reference of the rail, selecting the alignment of the wire forming over the cord strap between A and D, representative of the baseline. Trims, bingo panometers with the fixed with the measuring trolley B and line trolley C, connected with the wire with the means of the force wire with the driver to measure for the verse line with the geometrical property used within the method is explained below. Direction and work. Figure above show the H, A, B, C, D is in your trolleys, and then H2, H1, and radius. Your theoretical verse line is H1 is equal to AC times CD over 2R, and H2 would be AB times BD over 2R, and verse line ratio would be I is equal to H1 over H2 equal to AC times CD over AB times BD, and that's the independent radius of the curve. H1 is equal to I and H2. The machine does curve the correction flowing the point C with the verse line H1 if the correct ratio of the H2 is the H1 equal to I H2. Verse line ratio I is the property of the machine depending on the respective distance between the trial of the value of the I as various machines are listed in figure A and extra 29. 4-point lines for the location A with the taking of the reverse reference point of the subsequent correction. Therefore, important choose the initial point on the track of the current track geometry as pre-existing error with the initial point getting transmitted to track location being corrected with all subsequent corrections will also have the accumulated errors. Point A and B of the machine also remain with the corrected track with the corrective of the WRT of the previous position. Point D also remains on the portion of the track which is to be corrected with the lining of the correction that is done by the point C, and the machine system feeds H2 the system system. Multiply with a constant I to give the H1. The value H1 is fed with the difference amplifier and error. If there's any indicated in the galvanometer, the alignment is corrected at C by aligning the unit over the so the H1 becomes equal to H2I, or the ratio H1 over H2 is equal to I is maintained, and the galvanometer indicates zero reading. A machine with a having satellite unit with a constant I may vary due to the relative movement of position C. Overcome the problem, the compensation system will improve the automatically adjust the measuring locations. 2. Application of the 4-point lining method. The 4-point lining method can be used in the following situation: theoretical track geometry, either not known but not required by the dome. The track is aligned with according to the geometrical property of the existing curve. B. The due location of the track defects. Track's loading values are expected to so long that it cannot be implemented without additional measure to decide the smoothing of the curve rather than bring it to the targeted design profile. Lining can also be carried out according to the reference points by previous set. Slowing values also explained below. 210. Correction of the to be applied with the 4-point lining method. The curve to be correctly explained above, but it has further compensated with the following error of the air due to the front of the trolley being disturbed track. A variable curvature with the front trolley and the rear trolley on the curve with a different radial ratio of the H1 to H2 with the equal to for the I does not remain true. Likely the transition portion of the curve or while exiting or entering from one curve to another. Correction of the FD in 4-point lining due to the front trolley with a disturbed track. So you have your trolley A, B, C, D, and E. Direction, location, FR equals the FD over the D 4 point, and FD is over here over the side of D. In figure 210, when the curve marked with 1 show the target alignment, the 2 show the existing portion and position with the track with the beginning of the 10 with the 3 is correct with the alignment of the front trolley with the disturbed track. Point A and B, figure 210 with the previous line, the track with the point D with the front end of the core with the front end, front trolley with the disturbed track with an existing error of the FD with the result of the incorrect measurement of the reverse line with the H2 with the point C with the until the H1 is correct with the ratio and correctly measure the H2 depending on the distance of the measuring point with the fixed given the machine and an error remains in the lining of the point C as shown in figure 3. Shown in figure, which also calls left over the over error with the residual over the FR. Leftover FR is FD over times N to the 4 points, and error reducing ratios for NP 42. Number of the 4 points AD is equal to AD times BD over AC times PC. Value N4 depends on the trolley distance of the value as various machines given in annexure 2.9. The correct equal for the FD, the direction opposite of the needed to be fed with the front tower, eliminated with leftover air with the applied with the FR lining of the trolley. The FD value has been computed with the reading during the field survey to be done with the tamping either with the 2 methods of the made adopted for the field survey. They measure the first line with the reference for the rev of the track, which is generally termed for the disturbed track, with the calculating solution by suitable software realignment the curve with the deciding the target of the curve of the which be determined with the desired curve. Survey with respect to the fixed reference with the like reference call with the OHE map with the except for the ring force of the track with the targeted elimination alignment, which is determined by the designing lining. First line compensation or VU point lining in a location and changing the curvature of the simple curve with the transition E of the end with the corrections are applied with the following section with the curve for inch of the machine with the straight with the transition existing from transition to straight machine working in transition for every machine with the transition circular curve with existing with a circular with the transition curve when measures machines enter with the straight with the leading transition front trolley with the transition rear trolley with the straight with the measurement H2 to H and H1 are shown below. Alright, shows the direction work A, B, C, D, and those are your trolley H2 with H1 over H2 times I and V. The correct verse line C will be H2 plus H2 times I with the plus V, with the V is verse line compensation required with the bring back track target position above with the curve of the compensation towards the outside with the curve of the value with the compensation include the transition curve of the parabolic. The third degree will maximize V maximum V verse line compensation with the enter of the machine with the transition curve of the will remain constant. When the machine enters with the leading of the transition circular curve of the compensation reduce with the verse line maximum but eventually become 0 when the entire machine enters the circular curve. Similar when the machine enters the curve of the trailing transition from the trailing transition to a straight with a verse line compensation applied with the opposite direction as shown below. Alright, correction from the transition curve, the linear shows the radius is circular with it shows the low L, ST, L, VM1, TLC. Directional work L2, CT, L2, TS, VM, L1. Note verse line corrections applied with the trolley C, but is fed with the operator from the cabin, therefore written with the trolley D. Location C and D, the distance ahead were applied, and the above graph has been made accordingly. Here, the radius for the circular curve of the L1 and L2 transition lengths are either N LO of the chord length of the machine VM1 and VM2 of the maximum verse line compensation 2, and the value of the maximum verse line depends on the three-factor position of different trolleys of the tamping machine, length of the transition radius for the circular curve, and the workout by the formula verse line compensation maximum is equal to machine constant over L times R. Machine constant is equal to AC times CD times BC over 6 times AC times CD times BC as shown figure 2A. Variation of V is not linear with the zero of the maximum value M. The value of the verse line compensation different length with the transition radius of the curved along corresponding value with the verse line compensation and intermediate locations are given with the machine manufacturer instruction manual. Sample distribution of V of the chord length of the L0 L given the manufacturer instruction manual with the annexure 1010 of the guidance. The machine of the automated guidance computer system radius for the curve of the transition length could be fed into the automatic computer system feeding the compensation value done by the automatic computer system itself. Example, the two below explain with the method calculating corresponding verse line and verse line maximum values. For the remaining portion of the transition V is equal to Vm, the maximum should be of the direction of feeding is shown in figure 212. Note that the value of the written sleep of the verse line pentameter from the front cab and the front trailer above the location general principle file with the decide with the direction of feeding with the toggle switch verse line compensations as below. If the machine is entering large radius straight with the infinite radius, the low radius towards outside with the low radius to the large radius out toward outside verse line compensation direction different. Curve layouts are as below for the curve of the transition straight with the transition to the curve of the transition straight. So straight transition curve the direction of work, and then you have the straight start of the transition chord length transition L. Your direction adjustment verse line compensation M maximum end of transition chord length of the curve. Figure 2/4 of the curve transition straight with straight of the transition chord length with the transition L with adjustment of the verse line compensation with the chord length of the straight with the end of the transition and direction of the work. Compound curve radius is 1 is greater than radius 2 with the verse line 0 is equal to verse line 2 minus 1 and the curve 1 transition 1 curve radius 1 and to radius 2 the start of transition curve 1 machine base. Transition curve direction adjustment machine base end of the transition curve 2 resistant if radius 1 is less than radius 2 and VO is equal to V1 minus V2 then curve transition curve show the radius 1 start of transition machine base direction of the adjustment transition curve and end of adjustment machine base curve 2 and radius 1. Or your reverse curve of transition, reserves curve, the direction of work. You have radius 1, CT1, curved length, the direction of adjustment, verse line, compensation, maximum 1, chord length, the direction, adjustment, verse line, maximum correlation, tangent curve 2, and transition length 2, chord length. Alright, curve without transition. The curve with the transition correction values applied with the F with the verse line correction F with the machine with the entering the tray with the circular curve with the 0 with the target point or SC straight curve junction front trolley move with the circular curve with the value with the F that gradually increases until it attains the maximum value FM. That gradually reduces the move of the 0 with the rear trolley reach of the tangent point CS curve straight junction with the value of the FM is calculated given below. FM is equal to constant CF over R, and CF is equal to AC times CD times BC over 2 times AD plus BC. F will increase further to FM at a distance X from the straight curve junction to the curve straight junction with X is equal to AB AD times BD times over AC plus BC. Variation F is not linear. It depends on position of the trial with the radius curve of the different curve of the particular with the machine with the manufacturer instruction manual with the sample with the F value with the reference the radius curve for a particular machine supplied with the manufacturer shown in answer 211. The method of the F the feeding of a different curve of the configuration are given below. You have 1 the straight curve straight, which is shown with the straight curve and the F maximum chord length circular curve F maximum chord length and straight. Compound curve 1 to curve 1 2 radius 1 is greater than radius 2 the FMO is equal to FM2 minus F1. FM1 and FM2 are corrections with given the machine manufacturer curve 1 and curve 2 respectively. Show the radius curve 1 chord length and curve 2 and curve 1, 2, radius 1 is less than radius 2. FMO is equal to FM1 minus F2 with the curve 1, radius 1. FM maximum chord length, curve length 2, radius 2. Reverse curve FM S curve of the FM is equal to F1M or F2 with the curve 1 radius. Chord length reverse curve of the FMO, radius curve and the curve 2. Alright, models of tamping unit is 4-point lining method only for curve of the modes with the tamping 4-point lining method the correcting with the curve R. 4-point smoothing compensation mode with the mode with the tamping done with the base with the existing with the theoretical add with the track geometry without with the conducting with the lining survey. Over beginning with the end of the transition radial circular curve with the knee with the compass to calculate the verse line compensation value with the M maximum for maximum call with the back curve with transition F of the value maximum call with the VM value in case of the curve without transition value with the verse line corresponding maximum. It depends with the transition length with the radius value. It depends on the radius of the curve being over the bottom of the machine concept with the machine concept with the method existing with the curve smooth and how with the brought to the any with the targeted profile and machines the automatic gain automatic control system computer system is ready for the curve of the both transition length with the BFAB with the automatic control system, computer system calculation feeding with the VM value with the FM value done with the feeding of the V value done by the automatic control computer system. Alright, 2. The 4-point lining design and field surface with the curve of the 10 with the 10 with the 10 with the advance with the certain with the arrow FD with the targeted profile which can be designed with the desired alignment with a different location addition with the correction of the M and the V or FM and F acceptable with the design curve with the R and L with the radius and length taken in the curve for all calculation correction with the FG with the applied with the curve with the smooth with the also brought with the near targeted profile. In machines with the automatic computer system radius with the curve with the transition length with the B fed in with the automatic computer system input value with the V and M or F and M value with the done with the automatic computer itself with the system front offset values can also be fed with the into through the automatic computer system by making data file. These values can be found in the chosen intervals, say every 10 meters lower value of the 3 to 5 meters if desirable. Automatic computer system interpolates with the value of either every tamping location being between according and 4 values written, but sleepers also fed by operator's loop photometer. Annex 212 gives the examples showing stepwise procedure to be followed with the 4-point lining. Alright, 212, lining point method. The lining principle, the simple 3-point lining method can be used with the trait wells for the curve track with the crack is measured with the 3-point BC and the D with the line with the cord with a pre-specified with the theoretical verse line point C, cord measuring point with the B with the track with the 4 with the pedometer is measured off with the ordinating C only measured with the cord BD with the compared with the preset with the outfit ordinated value. Difference detected activating lining control to effect with the necessary correction. Show with the figure 2-2 with the direction color ABD and radius H1. Measuring chord with the between fixed B and D with the geometrical H1 is equal to BC times CD over 2R. Theoretical H1 is equal to BC times CD over 2R equal to the system constant over the radius. Theoretical verse line H1 and point C is dependent on the chord length of the given machine curvature alignment correction that's done with the theoretical verse line H1 is achieved. 2. Application of the 3-point lining method. The 3-point lining method may be with the track line according with the specified radius verse line with the straight track of the verse line taken in 0. Line system either the conjunction sighting device with the remote control with the laser. The corrections to be applied with the 3-point lining. And then it shows the corrected alignment, the targeted alignment, existing alignment, and above the point B with the already aligned track with the target alignment, behind with the machine with the front end with the core with the point D with existing with the track with the having lining air with the FT with the point C aligned with the H1 corresponding with the specified theoretical verse line with the D with the wrong style, wrong position with the trolley D, imbecile air the FR is equal to FD over number of 3 points remain with the need with the corrected air and the air with not corrected with all result with the wrong position trolley B with the next position tamping as the machine moves forward therefore with the air with the correcting position C for the accumulate increase with the machine is forward. MP3 is equal to BD over BC. The MP3 value with the available tamping machine listed in Annex 2-9. The lining error FD value computed with the readings that is taken during field survey to done prior to taking up with the tamping any 3 methods of adopted for the survey. Should be the respect with the reference with the get slew with within the error required with the bringing the track with the original design location with the WRT with reference wherever the provided Measurement of the verse line reference rail with existing track of the calculate slew with the use of the software realignment of the curve to get the desired curve of the slew value becomes the error. Recorded alignment to take the measure of the run with the automatic computer system, then deciding targeted alignment of the verse line error to achieve the calculated automatic computer system to consider the desired display location in front trolley. The FD is automatically taken with the tamping of the automatic computer system, that would be found separately. Correction of FD would be accordingly applied with the tamping without automatic computer system as shown below, and show the direction with a 3-point system, directed alignment, and targeted alignment, existing alignment. Alright, 214, determination target of verse line value with the 3-point lining, the math of the target verse line with the G with the C but with the verse line parameter in front with the cap of the verse line values, G with the trolley, C with the C, the distance from with the trolley, D, machine manufacturer accordingly given the verse line, the diagram of the feds with the trolley position discussed below with the following nomenclatures, U with the target verse lines, H equal the target verse line with the circular curve, the HX, HY, HZ, HW target verse line parabolic transition person India machine parameters shown as HA, HB, HC, HD. HV is the rate of the increased verse line and transition the target verse line to different points with the curve calculated shown below. Curve parabolic metric transition direction of work 2 and section X, Y, Z, W equal to the machine core length with the BD with the 3-point lining. First line curve is equal to H equal to the system constant value with over the R. Section X with the X, H, X, and section X is calculated divided prepared. Operation constant CXZ with the and for the XZ portion product of the radius L length 1, L length 1 is the transition to entry. HX operation constant value X and Z and CX and Z to over a radius of the times L1 equal to CXZ over the radius times L1 between X and Y after selection X is TC end of the transition first line increase with adding the 1 with the HV parameter HV system constant radius and length 1 equal to H over L1 section Y for the section Y is calculated HY is equal to H over minus H1 where H1 HW, where HW is equal to C, YW is equal to radius times 1, where HW is further defined, section Z is further section Z, HZ is equal to H minus HX, where HX is equal to C, XZ over the radius L2 length, L2's length and exit. Between S section Z and W after section Z till TS the verse line are decreased with subtracting HV per meter, where HV is equal to H over L2 for the section of the verse line. HW is the same with the formula. HW operating constant value Y and W for the C, Y and W for the R radius times length 2 with equal to CYW over the R radius times length 2. This operation is constant with the CXZ W2 web manufacturer manual, also calculated with the different machines. Example, the calculation varies for various are given below and show the chart. Here are the optional concept of the CXZ and CYZ for the given the manufacturer every 2 meters, therefore the calculation verse line 2 meters interval with may be calculated with the alternate sleepers. For portion of the X and Y transition verse line, end of the X is increased with the rate of the HV per meter with the length of the transition length with minus chord length, where at the end should be equal to the verse line starting the section Y. For the portion between X and Z and W with the verse line end of the section Z with the reduced the rate with the HV per meter with the length of the transition minus chord length, where the end of it is equal to the verse line starting in the section W. Calculation as shown in the 10 meter interval, which have the practical purpose of calculated every sleep with it interpolated with accordingly. Note these values are written on the sleepers. Prefed verse line pedometer with the front and cap of the front trolley above the location curve without the transition. Show the straight and circular H minus H to the X, V, X, F. Direction work X and H, in essence, straight single curve, straight curves, curves straight, curves, circular curve straight, and direction work H and HFW. HFX is equal to H times FX, HFW is equal to H times FW. Verse line H of the curve is obtained with the formula H is equal to system constant value over the radius operation constant FX and FW given the machine manufacturer manual. Alright, 215, mode of the tamping, either the 3-point lining method, the modes of the tamping, the 3-point lining method, the correcting curve of the 3-point elementary mode, lining of the mode of the tamping is done with the latest for the existing track geometry, theoretical average of without with the conducting finite field survey with the calculating shifts with the curve. Tamping is done either the calculated verse line H, HX, HY, HZ, HW, or HFX, HFW with the applicable the basic theoretical average track geometry, preferably, is certainly based on verse line measurement and feeding on the machine manually. In the machine for the automatic computers for the track geometry and the parameters for the radius for the curve, the transition detail for the head with the verse line H, H, X, H, Y, etc. are calculated with the automatic computers fed in the machine. And the mode for the lighting is sent to the front also, but it's not fed with the curve that is not brought through with another desired location air that is reduced with the curve that's not smooth within the front trolley error reflected correctly trolley position C. 2. The 3-point design mode lining. In a mode with the tamping done with the tree with the target with the desired design with the track geometry, have with the condition with the field survey with the track with the tending with the carried out advanced assertions of the air at existing track with different locations desired design alignment here calculated with the verse line H, H, X, H, Y, H, Z, H, W, or H, X, X, H, F, W, act with the basis desired design, desired track geometry for the correction, F, G with the tree with the desired design alignment is fed into the machine manually. Machines with automatic computers for the target with the track geometry for the parameters for the radius for the curve, the transition detail, and if the error of the required for the target profile with the federal to create with a separate computer with the data file with the targeted verse line H, H, X, H, Y, etc. calculated with the automatic computer system fed into the machine. The FD error can be alternately be fed through the front of the pentameter from the camera. The front of this is brought with the desired target geometry location with the target curve, taking calculation verse line values in FD. Measuring the run automatic computer system aligning mode with the machine with the automatic computer measuring the recorded curve with the correction of the curve done with the 3-point move of the target the desired curve with the parameters for the including transition detail, etc. is guided based on the recorded data for the head of the automatic computer system with the target with the verse line each of the line H, H, X, H, Y, etc. Calculated automatic computer system after taking into account with the FD of the different location for the desired target and general measure for the curve of the data for the correct curve of the accordingly. Answer 212 give an example to give it in step of the wise procedure followed with 3-point lining. 216. Comparison between 3-point and 4-point lining system. 3-point lining method can be used with both straight and curved, while the 4-point lining method should be only used for curves. Comparison of the two methods given below. 3-point elementary and 4-point lining smoothing. 3-point lining mode. First line the desired curve, the H, H, X, H, Y, H, Z with the H, V, etc. for the calculated base of the theoretical geometry. Existing curve of the chord length of the machine calculated verse line value with the head of the verse line parameter. 4-point lining smooth with the compensation for A. The circuit portion of the curve of the machine measure for the verse line, measure for the travel with the verse line line of the trolley, and correct with the measure to the verse line ratio for the transition verse line correction verse line maximum calculated based on the theoretical average of the geometry existing curve of the chord length of the machine is applied through verse line pentameter. B. The FD does not consider the residual error with the FD with the 3-point, depending on the chord length with the value with the third point with the 3-point machine working with the Indian Railways between 3 and 3.5 with the residual error is FD over 3 or FD over 3.5, approximately 1/3. Alright, number 3 and 4-point lining smooth with the compensation residual error with the FD with equal to number 4-point with the number 4 points between 6 and 7.5 with the residual error the FD is over 6 or the FD is over 7.5. Which gives a 13-16% approximation, and then it has their notes, 3-point and 4-point lining design mode. The 3-point lining design mode with the first line target with the H, H, X, H, Y, with the H, E, with the B, with the calculated based on the desired design curve with the geometry chord length with the machine calculated verse line value with the fed end with the verse line parameter. In addition, flowing value with the fed end with the front and tower with the slew parameters, and S number 4A, 4-point lining design mode for achieving the targeted design with the curve of the machine measure with the verse line measuring with the trolley 2, verse line trolley 1, corrected with the base of verse line ratio for the transition verse line with the verse line maximum correction calculated with the targeted geometry applied with addition feeding these values from the verse line parameter. In addition, show the above slow value of the fed in front of the slew parameter. Alright, 3-point lining mode is B. In machine with the automatic targeting control system, target geometry is designed desired for the meet the fed criteria with the automatic control system to have the D with the targeted alignment. Measuring run data with the U with the design with the desired curve of the line with the automatic computer with the consider with the correction with the calculator with the base of the measure for the curve of the profile with the targeted curve of the profile with the fed separately. Alright, your 4-point lining lining design mode is machine automatic control instead of the track geometry may be fed directly with the VM correction is applied automatically based on the radius and transition details. And then you have the 3-point lining design mode using layer system and 4-point targeting not applicable. 3-point lining D, the curve can be brought with a design desired to target geometry, and 4-point lining design, the curve has the smooth with brought the near design alignment, the desired alignment. Alright, 217, leveling of the track. Fixed type of the parallel cord leveling system provided on all tamped machines longitude level the both rails and cross level the correction. One datum rail and cant rail with the correcting longitudinal profile of the one of the rails selected with the datum base of the rail with the other. The cant rail with the machine correct with the datum and the main tim the cross level with the cant rail with the other rail within straight with the track with the reference with the datum rail, base rail which will be selected under the curves inner rail on the straight track with a double line unless disturbed rail, which is generally not processed, generally not cis rail. On straight and single line and straight middle track with a multiple line section, higher less disturbed rail. 2 selector switch and tempered supply with a pressure into cant selector switch is provided with the selector of the cant rail with a kept opposite with the datum rail base of the rail with the brush and tamper the datum selector switches provide selecting datum rail. Alright, 218 leveling lifting power system. Equipment that consists of the 2 cord wire on each for the rail with the second stretched tightly with the front of the tower with the rear of the tower tampering machines rectify level with the defect of the trail with the lifting with the reference for the leveling cords. High transition mount with the middle feed rod with the rest of the track with the lifting of the unit with the tamping with the both rail with the compare and controlled separately with the pendulums are provided with the left to right feelers to keep them both cords parallel and also measure cross level. So the working direction, R is your measuring point, M is the measuring correction point, and then F is the front measuring tower. Working height transducer that provides the metal feeler with the rod measure of the gap between the 0 and level of the cord wire with the datum rail with the lifted element with the rail of the gap of the rail cant rail lifted the being specified with the cam between the 2 rails which gives kept the 0 with the track with the equal to super elevation value of the curve track reduction rate ratio. Level the process with the front tower will also remain with unlevel the rear of the track. Rear tower level track with the process with the level of the defect with the tower location in from the front end of the cord goes out with the correct with the position equal to level. Offset with the position due to the incorrect position front end of the cord proportional level of the errors remain leveling. Thus level the track at M is having LF times A over A plus B equals to LF times Y divided by R. Where LF is the level offset at Y, the front tower R is the reduction rate of the equal to A plus B over A. Reduction ratio of various machines. Various machines have a different reduction ratio lifting values for this important portion area. 219, mode of working with leveling, tampering machine corrects leveling error with the following 2 methods. Smoothing, composition leveling mode method, long leveling defect with non-surveyed general lifting over the datum of the rail based on shortwave defects. Generally fixed or fed with the pentameter in front of the cabin longitude level the track smoothing and according to longitude level the design completely corrected thus the residual area FR remains. Lifting residual error target geometry track A plus B equals C, B, A, B, C. Residual error and M. On shortwave defect, the base of the machine can be smoothed with the super elevation curve of the correction with the K and X are discussed in paragraph 222, 2 and 3. Fed with addition of the machine with the automatic computers for the general lift of the curve, the detail of the design, the desire of the decide with the alignment of the correction. Maybe fed the automatic computer system in advance of the automatic computer system and automatically adjust the cant value within distributed with the SE transition length of the measure of the CMS general lift the ramp and ramp out with the displayed on the screen. Alright, design and precision leveling mode with the mode instead of the general lift with the lifting value with the achieving the target with a level based on the field survey with the general lifting pentameter over the datum rail over the recently 100% of the long wave short wave defect with completely remove the super elevation curve of the correction values X and K is fed in addition. Leveling cord target geometry of the track direction work Y and Y. And machine's automatic computer system, the target lifting value with the automatic computers with the preparing the data file with the writing of the sleeper while working on the curve of the radius for the super elevation transition length of the targeted design curve that can be evidence for the automatic computer system automatically adjust the can be fed through the disturb S and E transition length. No lift values every location written on the sleeper to be fed with the general lift the parameter for the front cab and the front tower is above the location. Alright, 3. Measuring run of the automatic computer system leveling mode for the level of the machine core length of the machine automatic computer system measuring run and recording with the tangent track with the curve to be done with the length of the track measure for the leveling of the cord is smooth and eliminated with the different peaks of the depths out with the long wave. Defect is not eliminated with the curve of the after sighting the target with the S and E with the particular portion of the cant distributed with along with the transition indicate with additional lifting of the track is required. Minimum maximum track lift of limits can be changed with the automatic controlling computer system and the track will be smoothed accordingly. 220 general lift. This amount of the lift given to cover over the undulation with the datum of the rail with the other rail with the lift of the maintained cross level super elevation is required with the reference corrected with the datum rail. More than saying general lift lifting with the track with the side based on the magnitude of the dips and peaks of the track with the target travel level of the datum should be such as always higher than the largest of the dips, certain with the permanent way supervisor advancing with the duly increase the value of at least 10 millimeters highest point and achieve uniform time surface. Therefore, the amount of lift is applied with the datum rail with will be the algebraic difference higher and lower datum rail plus 10 millimeters dips and peak with the side preliminary surface of the datum rail with the chord equal to the maximum chord length of 15 meters approximately, eliminating short wave with the defects high with the straight for the track with the datum is lower than the other rail. It should be more than one max cross level difference. 2. Quantum general lift. However, the fixing of the target level of the datum of the rail can be shown to take with a measure of the total lift value that does not exceed 50 millimeters at any point of the datum rail. More than 50 millimeters lift is required, but there should be undertaken with the 2-path of the tamping machine. If the lift is required is more than 30 millimeters, but less than 50 millimeter double insertion is with the same path tamped. The tool should be done. Minimum lift of the location should be 20 millimeters in effect with the tamping. Our general lift of the curve of the existing super elevation with the list of the equilibrium super elevation general lift of the equal tracking irregularities over the datum rail inner rail plus 10 millimeters such existing super elevation is more than equilibrium super elevation general lift will be track irregularity datum rail plus the difference between existing and equilibrium super elevation. Heart ramp in, ramp out. Value over the ramp. While giving the lift over the ramp to 1 and 1,000. Also closing the work ramp to 1 and 1,000. Ramp out should be 1 and 1,000. Should be given in the track with the smoothest transition to be lifted 1 and 1,000 existing track. Move the ramping method the ramp in and out. Closing with the opening of 2 successful blocks. Show the lift value of the ramp out. Previous ramp in the next lift value. Direction of work. Feeding of the ramp valve of the principle. The feeding lift of the front tower of the ramp is shown below. Figure 532 show the L over X equals the C over A over the R and show the rear front feeler, middle feeler, front feeler, A and B, and then if the machine ahead of the next position, suppose the lift Y has been given the front cab of the actual lift of the lift point M, it would be T equals X plus Y minus X over R. In other words, T is required with any of the position Y at the front tower should be Y is equal to T minus X over times R plus X. An example of the ramp out collection test for the exam 213. A machine with the automatic computers if the general lift of the value of the ramp gradient is fed through it or directly with the machine with the CMS give it the general lift of the ramp gradient and display it on the screen. R222 input and lifting with the cant values. The machine with the CMS for the tamp of the control of the unit mat 45 of the cross level inch of the working cabinet location M with the off of the other tampers with the fed with the front of the tower F. Adjustment of the track lifting valve with the general lift of the target height with the fed with the front reference with the front cabinet point with the F with the manual automatic proportional value with the transmit electronic control measure with the transducer on the mid feeler rod M measuring existing longitudinal level for lifting of the track with the gun until the difference between becomes 0. The method of feeding of the cant with the code of the machine the design of the feeding of the cross level of the front cab the following steps are followed. And it shows direction of work. It shows RMF and S1 to S2, 1 number, 2 SC, 1, 3, and 4, CT, 5, and 6, and CST, and 8. Total cant value distributed through the transition length with the rest of the weight 0 is S and T and S and maximized in T and C and C and T. Select higher rail and cant rail. Do not feed super elevation front of the F. The reach for the ST with the travel to increase N super elevation value with the 0 where M reaches the ST within F the distance between M and the distance between M and F away from the ST. Cross level XL feeding with the F therefore with the increase of the uniform rate with the time hour reach for the ST the desired value with the M super elevation position M is achieved with the cross level. The feeding with the F is according with adjustment nominally with the B rate of the cant gradient. The cross level value with the increase of the uniform rate with the cant gradient and with the till M reach with the tangent curve of the super elevation achieved with the air for the value of the cross level of the F would be for the super elevation position seen below. Or seen above. The value of the cross level of feeding of the F does not decrease the uniform rate with the maximum make it equal to the super elevation distance A between the radius R and M. Super elevation fit with the cross leveling F is equal to super elevation remains constant over the circular curve of the M with the N until the CT. At this point, starting the cross elevation till R each with the CT with the distance A with the value with the M and F should be required there. X super elevated cross level from the F is further reduce the uniform rate equal to the Kent gradient M reach of the TS value of the X across level the F is position would be negative. Beyond the negative cross level the F is increase the zero distance of the tilt R each of the TS. And the machines with CMS for the tamping and for the unit map 45 of the cross of the level for the working cabinet location M with the actual cam value, the M of the jump of the additional feed down with the cam with the plus or minus 10 millimeters per diameter may also recover the feed with the front side of the latest model machine with the provide with encounter additional feeding of the plus or minus 10 millimeters per diameter is not required much of the machine of the 10 plus or minus millimeters per diameter is not provided at all with the goblet meter does not come with the zero position desired cat cannot be achieved with additional correction between required to bring it to zero fed through the plus or minus 5 millimeter per diameter working cabinet at M. Two corrections X correction K to the cross level of the fed to do with the air curve with the curvature while with the curve of them both with the feeding and level and curve shift inside. Also height transit with the gift of the tilt with the causing extra lifting air with the K of the general lift of the lifting value Y fed. They're achieving the desired level of track general lift of the lift value with which have them reduced value called with the correction K. Correction value K is fed with a working curve with the equal to K is equal to constant is super elevation time the radius of the curve over the correction K value depends on the radius super elevation gauge for the track constant vary for the machine the mean stream of the K value with the deduct with the amount with the general lift to be given the front tower and the K value with the distribution given the below with the K with the correction depending on the curvature gauge with the super elevation machine supplied with the manufacturer construction manual sample included with the extra 214 direction of the work the transition K's and circular in transition. Attention vertical curve, the leveling of the core track both of the not comparable the machine works vertical curve, the requirement of lifting either more or less of the given the machine with the given the summative with the value of the curve respectively to account same general lift and value with the adjustment depending on the type of the curve accordingly intentional correction X applied general lift and lift values is shown and shows the A and radius R length 1 X plus N direction of work. For summit curves, X value start at the beginning of the sum of the double A with the as shown in figure 238 with the value X gets the edge with the existing lifting of the value of the reach and maximum of the completing level of the chord, the vertical curve of the X reduced to the end of the sum of the M becomes 0 point with the complete leveling of the chord side of the vertical curve. L is the leveling chord length. From valley sag curve of the vertical curve of the shown X value start at the beginning of the valley. Double A shown figure 239. The value X gets subtract with the existing lifting value that reaches the maximum completing level of the chord. Vertical curve of the X value reduced to the end of the length with the A becomes 0 with the point of the completing leveling chord out of the vertical curve of the L is the level chord length. Show figure 239 a valley curve. Alright, see the value of the X different vertical curves are given the machine manufacturer 1 sample and include the annexure 2A15. 223. Survey working tamping machines design over the guidelines. Survey with the track with the feature for getting the FD and Y operation tamping machine with the design method mode given in the annexure 216 with the method operation include the feeding of the requisite with the data of the various mode with the tamping are given in the annexure 212. Alright, we're going to stop the page here at 224, works required before doing and during and after tampering.